Hello there. So today we are going to continue solving trig equations, and we're going to start looking at factoring. So today your essential question is, how do I solve trig equations by factoring? The biggest thing here, and it's something that you saw in Algebra 2 and that you might want to write real big across the top of your paper and highlight it and underline it, is we cannot divide by trig functions. When you are solving equations and you see equal signs, you cannot divide by trig functions. What's going to happen there is you're going to lose solutions, and so you'll only get one or two of the answers instead of getting all of them, and possibly something might not even work out, so you'll think that there's no solution, but there actually is. So again, today we're factoring, and there's two different types of factoring, but the big thing you have to remember is do not divide by trig functions. So let's start, and we're going to look at a problem like this. So when you are trying to solve these types of equations, the big deal here is that I want to kind of get everything on one side of the equation. If there's trig functions happening, I want to get them all on the same side. And so I'm going to go ahead and I'm going to subtract sine x from both sides. Okay, now if you notice, these guys aren't like terms. They don't both have sine x, secant x in them. So I'm just going to rewrite as sine x, secant x, minus sine x, and that's going to equal to 0. So this has definitely got a common factor in it. So if you thought about back in the day when we had something that looked like, 2x squared minus x or something like that, you were allowed to take out an x. So in this one, I see a sine x in both parts of my expression, so I'm going to factor out that sine x, which leaves me with, in my first part, a secant x. And don't forget here, if you divide both of these by sine, that would leave you with 1. And so now what we're going to think about here is the zero product property. So when I had the zero product property, I set my thing equal to 0, and if I had factored out this guy, so that would have left me with 2x minus 1 equals 0, I can take this guy, set him equal to 0, or this guy, set him equal to 0, and that would find all of my solutions. Because if one thing is 0, then the whole expression is going to factor out. So I'm going to set each factor equal to 0. So my first factor here would be sine x. I'm going to use a different color. I would have sine x equals to 0. And then I would take my second thing, which is the thing in the parentheses, and I would take secant x minus 1 equals to 0. So I'm still using that same property as we did when we were just solving quadratics, but here I'm applying it to trig functions. So now at this point, these are two separate problems, and I'm going to go ahead and start with the pink side with the sine x. So remember, once I have one trig function on one side, I can just take the inverse trig function, the inverse sine of both sides, and then I ask myself, where on my unit circle does sine equal to 0? And there's two things you can do. You can draw out your unit circle and think about where is y equal to 0, which would be here at 1, 0, and here at negative 1, 0. Or you can draw your OIO chart. So remember, when you do that OIO, I owe you, oh, I don't owe you, and then we have SOHCAHTOA. And so if I'm looking where sine is 0, you're going to be right here and right here. And remember, on your OIO chart, this is 0, wow, that was terrible, pi over 2, pi, and 3 pi over 2, which would get you the same thing. I'm at 0 degrees, and I'm at pi degrees. So if I'm finding a general solution here, because remember, general solutions are going to help me find all my answers, for this first part, I would have 0, hey, what's happening? I would have 0 plus 2 pi n is equal to x, and I would also have pi plus 2 pi n is equal to x. So that's part of my general solution, okay? So then when I look and I want to find the rest of my general solution, I'm going to go ahead and get this guy. So in order to figure out where secant x minus 1 equals 0, I'm going to go ahead and get numbers away from my trig function. So I have secant x equals to 1. And so if you remember, when I have secant x, secant goes with cosine, and since this is just 1, if I flip 1 over, it'll still be 1. So I can go ahead and think about here, where does cosine x equal to 1? So if I take the inverse cosine of 1, and I can still use my OAO chart, or I can use my unit circle. So cosine is equal to 1 at those same places at 0, but not at pi, because pi is negative 1. So then this would only have one general solution of 0 plus 2 pi n. So now I go back and I look at my range that they gave me, and they said I want it including negative pi to pi inclusive. So I can use negative pi and pi in here. And so I go ahead and I write out my answers. So again, I'm looking at these 3 general solutions to find all the places in between negative pi and pi that this works. So 0 is one of them. That makes sense. And then if I think back to this guy, we'd have pi plus 2 pi n, so pi would work. And then finally I go back and I make sure that none of these other guys work. So if I had 0 plus 2 pi, that would be 2 pi, and that's outside of my range. If I had pi plus 2 pi, that's 3 pi, it's out of my range. But if I take pi minus 2 pi, because remember I could plug in a negative here, I would get negative pi. And so my 3 answers for this equation are negative pi, 0, and pi. And you would have lost that pi answer if you had divided by sign in the beginning, because then this general solution wouldn't have popped out. And all you would have got was 0, and so I would have had an issue there. Okay, so that's the first way. That is the GCF, the greatest common factor. Set each thing equal to 0 and find the general solution for each. So again, this is your answer. So let's look at one that is actually a straight factoring thing, and we saw this when we were doing identities. So I have 2 sine squared x minus 5 sine x equals 3, and we want it within this range. So we want to, again, set this equal to 0. In order to use your zero product property, it has to say equal to 0. So I'm going to go ahead and subtract 3 from both sides. So I get 2 sine squared x minus 5 sine x minus 3, because none of those are like terms, equals 0. And that's what you want to happen. And so remember, sine squared x, sine x, those are just variables, and you can factor them. So there's a couple of ways to do this. If you can figure out right here that this is just a quadratic equation, it's pretty straightforward. If you wanted to say, let sine x be some variable, so maybe like y, then I could say that this is 2y squared minus 5y minus 3 equals 0. Maybe that's easier for you to see when you're factoring. So remember, there's lots of ways to do this. You can do this by grouping, you can do the X box, whichever way is better for you. But in the end, what you're looking for is you are looking for the things that multiply to be negative 6, 2 times negative 3, 2 times negative 3, and add up to be your middle term, or negative 5. Okay, and so again, I'm looking for the things that multiply to be the a times the c, or the first times the last, and add to be that middle term. And so for this one, those 2 factors are going to be negative 6 and positive 1. Okay, and so then I'm just going to break out my middle term based on my little x here. So I have 2 sine squared x minus 6 sine x, sorry. Okay, and then I'm going to add 1 sine x. Again, I'm just using these things right here. Minus 3 equals to 0. And now I'm going to do my grouping thing. So I'm going to group the first 2 and the last 2 and look for greatest common factor in between them. So I see here these can both divide by 2, and there's a sine x in both of them. Okay, and then I would be left with a sine x, and then 6 divided by 2 is 3. Okay, there's nothing in common in this last one, so all I can do is pull out a 1, which is okay to do, and you should be left with sine x minus 3. And that's what you want to happen. You want these inside parentheses terms to be the same. That'll be your first factor. So whatever was inside your inside your parentheses, that'll be your first factor, and whatever was left will be your second factor. So 2 sine x plus 1 equals 0. At this point now, you can set each term equal to 0, each of your factors equal to 0, and then you can find all those general solutions. So if I take this guy and set him equal to 0, and then I take this one and I set him equal to 0, I'll find all of my solutions to this expression. Okay, so the first thing I'm going to do here is, remember, try to get my trig function on one side by itself. So I get sine x equals 3, and I would take the inverse sign of both sides in order to find x. Now, if you think about two different things, if you think about your sine graph, or if you think about a triangle, remember, you would be trying to make a triangle that has the opposite side of 3 and the hypotenuse of 1. That's not going to work, okay? We can't have my hypotenuse be smaller than one of my legs. So for this part of the solution, it doesn't matter. It doesn't work. It does not exist. So we're going to be focused on the second side and hope we can pull some solutions out of this one. Okay, so again, we kind of get to ignore this side because it didn't work out. So let's go ahead, and on this guy, we're going to subtract 1 from both sides and then divide by 2 because I'm trying to get my sine by itself. And now I'm going to take the inverse sine of both sides. This one is much nicer. I have a number less than 1. I recognize that as something on my unit circle, so I can go ahead and find some general solutions over here. So if I draw my unit circle out, and I remember the principal inverse value for a negative sign is going to be down in quadrant 4. So opposite over hypotenuse, complete my triangle, and I would recognize that this is a 30-degree angle. Okay, but remember that I'm in radians, so I'm going to write this guy as negative pi over 6 plus 2 pi n for all those coterminals. Okay, and then I have to remember there's one more solution here, and that is going to be over in quadrant 3. Same reference angle, so in order to get to here, there's a couple things I could do, but if I take 180 plus pi over 6 or pi plus pi over 6, I would get 7 pi over 6. So remember, our general solutions are going to help us find those values within my set. Okay, so those are my two general solutions. I go back and look at my original problem. I want to find those values of x in between 0 and 2 pi that work out. Remember, I didn't have to worry about this side, but I will have to get some answers from this side. So my first one that is bigger than 0 in here is going to be 7 pi over 6. And then I can go ahead and I can take negative pi over 6 plus 2 pi, and that would be 12 pi over 6. And I would find the other general solution was, not general solution, the other value within that range would be 11 pi over 6. And again, make sure that those are the only two. If you keep adding 12 pi over 6 to these, it's going to get you a value with outside of that range, and so I just leave it at this. Okay, so those were the two ways that I can solve trig equations using factoring. Just remember, you cannot divide by trig function. You're going to try to factor it out, but then you've got to set it equal to 0 and use your zero product property.